In this video, I'm going to show you how to use some of the provided functions in your decision algorithm for your tank. So if you go back to GitHub where you downloaded the code, there's a README file, and you can read through this. You'll probably find a lot of helpful information, particularly where it talks about the different moves your tank can do, which are all of these 7 moves. And then it has all of the functions that your tank can call in order to figure out where the other tanks are in the arena, where all of the bullets are in the arena, so that you can decide whether they're close to you or whether you need to worry about them. Anyway, so let's just go through and try out some of these functions. So we have one called rotate right, and it doesn't return anything. See, it's a void function. So let's just make it so our tank always rotates right. Rather than doing this random stuff, I want to start fresh and show you what it would be like. So we could just say rotate right. Now the Paul tank will always rotate right. So the timer starts, and they're always rotating right. So you can probably guess what rotate left would do, what move up would do, what move down would do, move right, move left, and fire. It's pretty self-explanatory. So you just have to type in that actual command, whatever it is, and that's what your tank will do every time. Of course, to make it a decision algorithm, we need some if statements. So we could say something like, how about every other time let's rotate right, and every other time let's rotate left. So let's just say I create a counter variable inside the tank class. Let's say int counter equals 0. Now this is a member of the Paul tank class. That's why it turns green. And that way I don't have to keep creating a new one inside the tank action function every time, because that wouldn't even work. If I tried to change the counter every time the tank action was called, I have to have a variable that's created outside of the tank action function. In here I can say counter plus plus, which will increase it by 1 every time. And then right here I can say if counter mod 2 equals 0, we'll have it rotate right, and otherwise we'll have it rotate left. So you can imagine what's going to happen now. Every other time it'll switch back and forth. It'll go left and then right, left, right, left, right. And it appears some of them are out of sync with others, which I'm not sure why that would occur, but I'm not too worried about it. Okay, that's not a super intelligent decision-making algorithm, but at least we have some conditional statements, so it's actually making a decision. And we probably want this decision to be made based off of the current situation of the arena, where the tanks are, where the bullets are. So let's try using some of the other functions. So if we go down, we have several more functions. We've got one called getNumCalls, which will return the number of columns in the arena. We've got another one that says getNumRows. Of course, that'll return the number of rows that are in the arena. And then we have one that gets an X value and another one that gets a Y value. And you can call these functions on a game object. And by the way, both bullets and tanks count as game objects. So if I access a particular tank, say for example myself, by using the word this, I could say this.getX. And that would give me my current X coordinate wherever I am on the arena. And of course I could say this.getY to get my current Y coordinate where I am in the arena. Of course I want to know where all of the other tanks are, so let's see if there's a way to access all of the other tanks. And sure enough, down here it says there's a function that will return a list of all of the active tanks in the arena. And of course it's in read-only form, so that you can't edit somebody else's tank. That would be against the rules. It tells us the function to call is getTanks, and the type it returns is a list of tank objects. So let's just do that. Let's create a list of tanks. Say list tank, and let's just say tanks equals, and then here we call that function getTanks. So I'm going to type getTanks, and I just have to import the list class. Now I have a list of tanks that are in the arena. So I could probably look through them one by one and figure out where they all are. Let's see if we can do that. So let's just say for every tank, and we'll give it the name T, inside the tanks list, we'll do something. And let's just get its X and its Y. So let's say system.println X, and we'll say T.get X, and then we'll say Y, and we'll say T.get Y, missing a plus sign. Okay, so let's just run this. And so every single time it calls this function, it's displaying the X and Y coordinate of every single tank. Obviously, that's displaying at a rate too fast for us to be able to read or make any sense of it, but it's all happening. So you can imagine this kind of information will be helpful in making your decision. Because you could check through all of these tanks and say, if any of these X coordinates is within 3 spaces of my X coordinate, maybe I want to fire at them or something, right? Okay. And let's actually look at the bullets too, because that'll be helpful. You can access the bullets in a very similar way. We just have to save a list of bullets and call the function getBullets. So let's say list bullet bullets, or whatever you want to call it, equals getBullets. And then we could iterate over all of the bullets. And we could say if any of the bullets X coordinate is close to us, so let's say if b.getX is close to Rx, let's actually turn this into a subtraction and comparison statement. So if the absolute value of b.getX minus this.getX is less than 3, then we know that there's a bullet within 3 columns of our tank. And you'd of course probably also want to check that it's on the same row as you, otherwise you probably don't worry too much about it. Let's say in this case, let's move up. And by the way, because we did an action move here, it's going to completely ignore these actions. Even though the code might come down here and run these, it only evaluates the first move you choose. I programmed it that way. And let's actually change the file so that it's a 1 versus 1. And just to test this actually works really quickly, let's change the dumb tank so that it always fires. So we'll just delete all of the decision code here, and we'll just say fire. So every single time the dumb tank will be firing. So the dumb tank's going to fire at me, and as soon as it gets within 3 spaces of me, my guy moves up. And it kept moving up because I didn't actually check which row the bullets were on. So even though I'm far enough away that the bullets won't hurt me, I still was only looking at the X coordinate of the bullets. So we can make it smarter if we say if it's within 3 columns of us and its Y value equals our Y value. So let's try it again. And this one's not going to work because he's not facing us. So let's try it again. This time it'll work because he's going to shoot us. As soon as it gets within 3 of us, we jump up. And then we're no longer in danger, so we don't worry anymore. Okay, there are only 2 more functions here that you need to use if you want to make it a smart tank. One of them is called getRotateDegrees. This is one that shows you the direction the bullet is moving. So if the bullet's rotate degrees are 0, it means it's going to the right. If its rotate degrees are 90, it means it's going down. And 180 is left, 270 is up. So you can compare those rotate degrees with the value 270 and with the value 90 to figure that out. And the same thing goes for tanks. You can figure out which direction a tank is facing by asking what its rotate degrees are, using the same function on a tank. Okay, and the last one here is called isBulletsOwner. This is a way for you to check whether a bullet that was shot is your bullet, because your own bullets won't kill you, so you might not want to worry too much about them. If you're iterating through a list of bullets and you're doing something depending on where the bullets are, you don't want to worry too much about the bullets that you didn't fire. So that's where this function comes in handy. And when you get to that point, I can show you how to use it. Okay, good luck.